So we're looking at our last conic section, which is a hyperbola. So a hyperbola, by definition, a hyperbola is a set of all points in a plane where the difference of whose distances from two fixed points, the foci, is a constant. Okay, so just like a parabola, the parabola shape was facing towards our foci. This hyperbola, it's not really two parabolas facing or going away from each other, but it looks like it. So for this hyperbola, where the parabola shapes are going towards the x direction, we have the focus here, and here we would have foci down here and up here. The transverse axis is this distance in here, which is 2a. So the distance from the center of the hyperbola is a to the left and a to the right. This conjugate axis is 2b. So I'm actually going to go up b units, and I'm going to go down b units for this center, from this center. So technically what happens is if you form a box shape, with these points, notice that these dotted lines, these are actually oblique asymptotes. We get these oblique asymptotes, two of them, by going through the diagonal of the corners of that rectangle. And our hyperbola shape is going to be following those. So here we would go up a units, down a units, to the left b units, and to the right b units. We would form this box. And we can get these asymptotes. So I look at this when I'm looking at a hyperbola to tell which direction it's going. I look at which value does not have the minus in front of it. So the minus is in front of the y value. So the x value has the positive. So it's, I know, will be going towards the x-axis. Over here, it's the y value that is positive. And so I know that the hyperbola shape is going towards the y values, positive and negative. We have a center at HK. This case, C is equal to a squared plus b squared, the square root of that whole thing. And that will help you find the foci. They have a formula in front of you so that you can find those equations of our asymptotes. I don't have those memorized, but I know that asymptotes have to go through the center, and I could find one of those points, or both of those points on that box, and I know how to find the equation of the line given 2 points. I can find the slope, I can find the y-intercept, and I can put it in the form y equals mx plus b. So let's go through and look at an example of this really quickly. So right now we have 2y squared minus x squared plus 2x plus 8y plus 3 equals 0. So I recognize that this is a hyperbola because I have an x squared and a y squared term in there. The coefficient in front of the x squared and the y squared are not the same. One is 2 and one is -1. So if they're not the same, if they're the same, it's a circle. If they're not the same and they're not the same sign, which they're not, I have a +2 and a -1, that clues me in that this is a hyperbola. So I want to group my x terms together, I want to group my y terms together, and I want my constant on the other side. So rewriting this, I could rewrite this as 2y squared plus 8y minus x squared plus 2x, and subtracting 3, I get equals -3. I want to complete this square on my x terms and my y terms, but I can't do that until my coefficient in front of the x squared term and the y squared term is 1. So for the y terms, I'm going to factor out my 2. And doing so, I get y squared plus 4y. I'm going to want to make this a perfect square, so I'm going to add some number here to make it a perfect square, and my parentheses. So for my y terms, I need to factor out the -1 from both of those x terms. So factoring out a -1, I have negative x squared minus 2x. I'm going to add something in here to make this a perfect square. It is equal to -3 plus, so I added on this left-hand side this 2 times whatever I'm adding inside that parentheses, so 2 times something. I also added on that left-hand side this -1 times whatever I put over here, so plus -1 times something. So figuring out what we're putting inside the parentheses to make that perfect square, I'm dividing 4 by 2, which is 2. 2 squared is 4. Technically, because of this 2 coefficient out in front of that parentheses, I have 2 times 4. So technically, I have 8 here that I added on the left. Same idea over here. I'm going to take half of this middle term, -2, which is -1, square that number. -1 squared is 1. So I technically took -1 times +1. So I added a -1 here. So let's rewrite one side. So I have 2. This is a perfect square of y plus 2 quantity squared minus, and this is a perfect square here, x minus 1 quantity squared equals, we'll have -3 plus 8. That is 5. 5 minus this 1 gives me 4. So ellipses and hyperbolas, those are always set equal to 1. So I need to divide both sides of my equation, in this case by 4. We don't want that coefficient in front of the quantity square. We want it to be 1 in that numerator. So let's simplify this first fraction. We have y plus 2 quantity squared all over 2 minus x minus 1 quantity squared all over 4 is equal to 1. So here I can tell my center, HK. H is always with the x value, opposite sign, so +1. K is always with a y value, so -2. So I figured out what my center is. Looking at this, I determine which one is positive. The positive is in front of the y terms. So this tells me right here that my hyperbola shape is facing towards the positive y numbers and the negative y numbers. I know my center here is 1, -2. So I want to find my vertices. My vertices are always on the transverse axis. So for our transverse axis, I'm going to look at this value down here. So I know my transverse axis well, its length is going to be the square root of 2. So I'm going to go up root 2 and down root 2 from the center. So vertices on the transverse axis. So from my center, 1, -2, I'm going up, so -2 plus root 2, and I'm going down, so 1, -2 minus root 2. So my conjugate axis so look at the negative value. So the number in the denominator is 4. So I'm going to go up or left and right. And that is 2, square root of that. So left and right affects the x value of my vertex, or center, I mean. So 1 minus 2, comma, -2, and 1 plus 2, comma, -2. So let me just graph that really quickly. So I have a point at 1, -2. That is my center. Vertices, so I have 1, -2, plus or minus root 2. So that is going to be a little bit above the x-axis and a little -2. Minus root 2 is a little less than -4. The other one, I would have -1, -2. And I would have 3, -2. So let's make a box with those vertices on the transverse and conjugate axis. Let's make our asymptotes by going through the diagonal in the center. I'm running out of time, so I'm not going to find these equations, but you should be able to find these equations because you have 2 points on a line. I know that my vertice is right here, and I'm going to be hugging these lines in here. If I was trying to find the focus, I would figure out what C is. Focus is always going to be, these parabola shapes are going to be going towards the foci. And I could do that because I know that C is equal to the square root of A squared plus B squared. So C in this case is the square root of 2 plus 4. C is equal to the square root of 6. So from the center, I would go up root 6 and down root 6 to get those foci. Okay, so I'm out of time, I'm over time, so I'm going to stop there for today.